They're invisible, inescapable, and almost incomprehensible. Black holes, the most extreme objects in the universe. Born from collapsed stars, they warp space, slow down time, and devour everything, even light. But what happens beyond the event horizon? In this video, we dive into the science of black holes, from how they form to how they distort reality, and what might lie at their mysterious core. This is the science of black holes, beyond the event horizon. What is a black hole? Let's start simple. A black hole is a region of space where gravity is so strong, not even light can escape. That's why it's black. No light, no information, nothing gets out. At the center of every black hole lies a singularity, a point of infinite density where the known laws of physics break down. Surrounding it is the event horizon, the boundary beyond which escape is impossible. Cross it, and you're gone. Black holes aren't empty. They're incredibly dense. Imagine squeezing the mass of our sun into a ball just a few kilometers wide. That's the gravity of a black hole. How are black holes formed? Most black holes form from dying stars. When a star many times the mass of our sun runs out of fuel, it collapses under its own gravity. If the core is massive enough, it doesn't stop collapsing. It keeps going, crushing itself into a black hole. There are also supermassive black holes, millions or billions of times the mass of the sun, sitting at the center of galaxies, including our own Milky Way. How do those form? That's still a mystery. They may start as small black holes and grow by eating stars and gas, or they may have formed directly from huge clouds of collapsing matter in the early universe. Anatomy of a black hole. A black hole has three key parts. Singularity, the infinitely dense point at its core. Event horizon, the no-return boundary. Once you cross it, not even light can escape. Accretion disk, the bright swirling ring of superheated matter orbiting the black hole, visible in images like the one from the Event Horizon Telescope. Around the event horizon, time slows down due to intense gravity, a consequence of Einstein's theory of general relativity. To an outside observer, an object falling into a black hole would appear to slow down forever. To the object itself, it would fall in and vanish. How black holes bend space and time. Black holes don't just bend space, they bend space-time. Imagine space as a stretched rubber sheet. A planet makes a small dip. A black hole, a deep, infinite well. This curvature affects time itself. The stronger the gravity, the slower time flows. Near a black hole, seconds stretch into minutes. In theory, you could use this to time travel into the future just by orbiting close to a black hole and returning. But get too close and you won't return at all. This is called gravitational time dilation, and it's been confirmed by physics. Black holes are not just holes, they are engines of warped reality. Can you survive a black hole? Let's imagine falling into a black hole. If it's a stellar mass black hole, you'd be spaghettified, stretched thin like a noodle, by tidal forces. Your feet would experience more gravity than your head. It's not pleasant. But with supermassive black holes, the tidal forces at the event horizon may be gentle. You might not even notice crossing it. But once you do, there's no turning back. What happens after that? No one knows. Some theories suggest you'd be crushed at the singularity. Others suggest the singularity may not be a point at all. Maybe it's a portal or a bridge to another universe, what physicists call a wormhole. But these are only theories. Hawking radiation and the death of black holes. Stephen Hawking changed everything. In 1974, he proposed that black holes aren't truly black. Through a quantum process near the event horizon, black holes can slowly emit radiation, now known as Hawking radiation. Over time, this causes black holes to lose mass and eventually evaporate. It would take longer than the age of the universe for most black holes, but it means they aren't eternal. Even the most powerful objects in the cosmos eventually fade away. What lies beyond the event horizon? This is the biggest mystery of all. What happens inside a black hole? Do the laws of physics break down completely? Does the information of everything it swallowed disappear? Or is it stored somehow, holographically, on the event horizon? These questions touch the deepest problems in physics: how to unite quantum mechanics with general relativity. Some physicists believe black holes could even contain the seeds of new universes born from collapsed matter. We simply don't know. To explore it, we'd need a quantum theory of gravity, something no one has cracked yet. Why black holes matter? Black holes aren't just cosmic monsters. They are labs of extreme physics, pushing the boundaries of what we know. They shape galaxies. They warp time. They may hold answers to the origin and end of the universe. And the deeper we look into their darkness, the more we learn about the light of understanding. This is the mystery of black holes. And we've only just crossed the event horizon,